Hi, welcome to Jump a Grade Coordinate Geometry Quick Start course. In this course you're going to review and revise all the knowledge that's needed to get a great result in Leaving Cert, the topic of the coordinate geometry. So let's get right into it, no point in wasting time. Coordinate geometry is the type of mathematical technique or set of mathematical techniques that help us figure out what is happening on a plane. And the blank screen that you see in front of you right now is the best representation of a plane that I can think of at the moment. Plane is essentially a two-dimensional infinite shape. So it has length, which is infinite, and width, which is infinite, but it has no thickness. Now the problem that arises is if I draw a point, just like this one, or if I draw a shape, just like this one, a little stick figure, or if I put a box, or it's actually not a box, but maybe a square somewhere on the plane. The question is, where is it? Where is that point? How do I know its location? Where does Johnny stand? How do I know where he is? And finally, where did I place this square? It actually turns out that coordinate geometry helps us figure out the answers to all those questions. Coordinate geometry starts with the number line. And I'm sure you all remember number line. It's a line on which we start with putting 0 down. So we mark a point on that line and we say this is where 0 is going to be located. And then once we figure out where 0 is, we start adding units to the number line. So first we add 1 unit. We figure out how long that 1 unit will be, and we say this is 1 unit. This point is 1 unit away from the 0 on the number line. Then this is 2 units away. We have 3 units, 4 units, 5 units, and so on. And by convention, we agreed that going to the right hand side of the number line is going to be positive. That's where we add the arrow. So arrow indicates where the number line is positive, again by convention. This is just an agreement that people made. And in a similar way, by convention, or actually not by convention, anything to the number line, anything to the left, anything to the left of 0 on the number line is going to be negative. So to the right we have positive numbers, to the left we have negative numbers. We can flip it around and have positive to the left and negative to the right, but the most common agreement is what we're seeing over here. And if I place Johnny right here on the number line, it's very, very easy for me to say that Johnny is located at a point called 4 on the number line. So the coordinate or the location of Johnny on the number line is equal to 4. So that's very useful if I'm dealing with something that's one-dimensional, but obviously that's not very common. So to figure out solution to this problem, I just add one more number line to the mix. And I draw this number line at a very specific point. I draw it at point where I marked 0 on the first number line, and I make sure that the angle that I draw the two number lines is 90 degrees. So there is 90 degrees between the two number lines. And now if I put Johnny somewhere in this location on my plane, I can figure out that, okay, so Johnny is actually 4 units away from the 0 point along the horizontal number line, and he's located about 1 unit away from the 0 point along the vertical axis. So I can say that Johnny is located at a point with numbers equal to 4 and 2. So a couple of things. First of all, this point where the number lines intersect is called the origin. The origin of the coordinate system. The whole thing that we're just looking at is the coordinate system. Next thing is that by convention we say that the horizontal axis is called x. And also by convention we say that the vertical axis is called y. So again, axis is a single number, is single. So we have x-axis and y-axis, and then we have axes, which is plural of axes. So if I say axes of coordinate system, I mean two of them. If I say x-axis and y-axis, I just refer to a single one of them. And I want you to be very cognizant of this particular fact, that I always keep the same order of the numbers that I use to indicate location. So I always write the number along the x-axis first, and then I write the number along the y-axis second. So the number along the x-axis is the first, and the number along the y-axis is second. And those two numbers, the two numbers that I write down to tell me where Johnny is located on the coordinate system, these are the coordinates. So by knowing the coordinates, or the location along the horizontal and the vertical axis, I can figure out the location of any point in the coordinate system. So for instance, this point over here, it's -4 units along the horizontal axis. I'm going to write that number first, put a little comma down, and then say that's 4 units up along the vertical axis, so that's +4. Coordinate of this point is -4 and 4. Let's take a look at this point over here. So it's -2 along the horizontal axis, that goes down first, and then -4 along the vertical axis, that goes down second, and I'm ending up with -2, -4 for my coordinates. And I can do the same thing for all the points in the coordinate system. The person who came up with the idea of the coordinate system is this gentleman in the left corner called René Descartes, and his name is spelled D-E-S-C-A-R-T-E-S, Descartes. And this last part of his name is what gives the name to the coordinate system. Because his name is Descartes, we call the coordinate system, as described in this video, Cartesian. So in the Cartesian coordinate system, we have two axes which are perpendicular to one another, and we agree which axis is x or y or any other names, and we use the two coordinates or the two numbers along those axes to tell ourselves the locations of the points in the Cartesian coordinate system. There is actually an interesting story on how René Descartes came up with the idea for the coordinate system. So apparently one day he was lying in his bed and looking at his ceiling, and his ceiling was made out of lots of small blocks of wood. Essentially it was like a wooden tile in a square shape. And he was looking at bugs that were walking along the ceiling, 16th century or 17th century, which was when he was thinking about this. I guess they didn't really have any raid available to get rid of the bugs. Anyway, Descartes was wondering, how can I tell myself, or how can I tell my wife where that bug was on the ceiling? And he figured out that if he took one of the blocks or one of the points on the ceiling and told it, okay, this is my 0 point, and then counted the number of the blocks along the edges of the ceiling, he could figure out how many blocks away from the origin, from the first point that he set up, was the bug located. And just by thinking about this, by looking at those bugs, he came up with the idea of the coordinate system. And now we can use the coordinate system to figure out numerous things. We can find locations of points on the coordinate system. We can figure out what are the relationships between lines, circles, triangles, and other shapes. But it all starts with this very, very simple idea. And the idea is that on a plane, we put together a coordinate system consisting of two axes. Both those axes are located at 90 degrees to one another. We select a point that we call the origin with coordinates of 0 and 0. So that's the start of our coordinate system. And then in relation to that point, we can figure out the location of any point in the coordinate system simply by noting the distance along the horizontal and vertical axes for that point. So the distance from the origin for a point over here along the vertical axis or horizontal axis is 4, along the vertical axis is 2. Again, for this point, minus 2 and 2. And I can do it for all the points in the coordinate system. So that's it for the first part of the introductory of this course. And in the next video, we're going to take a look at relationships between different points. So thank you for watching, and see you next time.